Hi, my name is Aina. What is your name?
Hi Aina, my name is Arif. I am a chemistry student.
Nice to meet you, Arif. I'm also a chemistry student.
Haha, yes.
Let's play some chemistry quiz.
Haha, okay.
What is neutralization?
A reaction where base and acid reacts with one another to form salt and water.
Very good. What is oxidation?
A reaction where it involves the transfer of electrons and oxygen between atoms.
Okay, last one. What is the collision theory?
Uh,
Good day, students. My name is Arif Iskandar bin Amdan, but you can call me Sir Arif. Good morning, sir. Today, we will go deeper in topic 7, rate of reaction in chemistry form 4. But more specifically, we will go deeper in subtopic 7.4, collision theory. Let's go. These are the following learning outcomes for this subtopic. At the end of the lesson, students are able to first describe the collision theory. Second, explain activation energy using examples. And lastly, interpret an energy profile diagram for exothermic and endothermic reaction. Before we start, have you ever wondered how do reactions occur? Previously, we have learned that reactions were formed by interactions of particles. But what kind of interactions do particles need to perform in order to produce a reaction? How does the interaction of a particle affect the rate of reaction? And is there a way we can interpret and even explain these phenomena? Well, you're in luck, students, because that's where collision theory comes in. So, what is the collision theory? The collision theory is a theory which explains how particles react with each other to produce reaction and form products. Now, there are two main key points in collision theory. First, reactant particles must collide with each other to produce a reaction. Second, the rate of reaction depends on the frequency of effective collision. Now, in simpler terms, in order for a reaction to occur, the reactant particle must collide or experience collisions with each other. But remember, not every particle collision would guarantee a reaction. It must be an effective collision. Effective collision is a collision that produces energy equal or more than the activation energy needed for reaction to occur, and effective collision requires the correct orientation during collision in order for it to be considered an effective collision. Hence, the higher the frequency of effective collision occurring, the faster the reaction occurs. Hence, the higher the rate of reaction. I'm sorry to interrupt, sir, but what is activation energy? In order to start a reaction, a particle must have enough amounts of energy. This amount of energy is called the activation energy, which is the minimum energy required to break the existing bonds of the reactant particles to form new bonds, to form new products. Think of activation energy as a hurdle the particle must overcome in order to produce a reaction. It is also worth noting that different reactions have different activation energy. Previously, we have learned two types of reactions, which are exothermic reaction, where heat is released at the end of the reaction, and endothermic reaction, where heat is absorbed at the start of the reaction. When we talk about activation energy, we need to talk about energy profile diagram. An energy profile diagram is a theoretical representation of chemical reaction which consists of reactant, product, and energy level throughout the progress of reaction. It is worth to note that EA in the energy profile diagram represents the activation energy needed for the reaction to occur. Note that the total energy of reactant is higher than the product for exothermic reaction, whereas for endothermic reaction it is vice versa. Exothermic, endothermic, exothermic, endothermic. Okay, sir. Thank you, sir. I'll try. When Sir Arif mentioned about collision theory, I believe he said something about orientation. Can you please elaborate more on that matter, please? Sure. In order for a reaction to occur, reactant particle must collide with sufficient amount of energy and also must be in specific correct orientation in order for effective collision to occur and to produce a reaction. This is to ensure all bonds are broken and new bonds are formed. If the reactant particle collides with an incorrect orientation, no reactions will occur and the particle will simply bounce back away. Boom! In contrary, if the reactant particle collides with the correct specific orientation, new products would be formed and reaction occurs. So Arif, how do we apply this theory in rate of reaction, let's say? Well, my dear students, there are several factors that we can use to affect the rate of reaction based on the collision theory in terms of concentration, size of reactant, temperature, and presence of catalyst. Please, Sir Arif, please teach me your ways, please. In terms of concentration, let us compare both of these beakers, beaker A and beaker B. Beaker A has more number of particles than beaker B. Thus, beaker A is more concentrated than beaker B. The higher the number of particles per unit volume, the higher the frequency of particle collision. Thus, the higher the frequency of effective collision. Thus, the rate of reaction increases. Okay. I think I got some little bit of idea on that. I'll look more on that later. Sorry, sir. What about size of reactants? Let's take a big chunk of particle A. As you can see, only the outermost layer of the particle is exposed to collision with other particles. Whereas if you break down that same chunk of particle into smaller piece of particle, this increases the surface area that can collide with other particles. So this means decreasing the size of reactant will increase the surface area of particle that is exposed to particle collision. Thus, frequency of effective collision will increase, and in turn will increase the rate of reaction. So Arif, can you tell me more about effects of temperature? As for temperature, we must first understand that by increasing the temperature of the beaker, we are supplying energy to the particle within. So when the temperature increases, the kinetic energy of the reactant particle also increases. So more particles will have the energy needed to overcome the activation energy. Thus, the frequency of collision and effective collision will increase. Thus, the rate of reaction will also increase. Last one, sir, please. What about the presence of catalyst? Does it affect rate of reaction in sort of way? Presence of catalyst creates an alternative pathway to a reaction by lowering the activation energy. So, less energy is required to overcome the activation energy to produce a reaction. So, in the presence of catalysts such as nickel, iron, and enzyme, more reactant particles can achieve effective collision, thus increases the rate of reaction. Yes. Oh my, I think I got it now. Thank you, sir. I can't believe it. I finally understand collision theory. So, to recap today's lesson, we have learned how to describe the collision theory, explain activation energy with examples, and lastly, interpret an energy profile diagram for exothermic and endothermic reaction. So I guess that's all for today's lesson. I hope that you at least have an idea of what we have learned today. I'll see you later, and thank you for your attention. Let's go.
So yeah, collision theory is literally just like that, and yeah, I think collision theory is one of the most important thing that